So I think I wanted to talk about how I use LaTeX for school, primarily for math, uh, as well as other science. Sometimes you can use it for computer science, but I thought I'd just go through um, how I use it. So what I downloaded, what editor I use, and then how I just format uh, generally my problem sets using LaTeX. So for I guess anyone that doesn't know what LaTeX is, it's just it's a type of text editor. So you can think of it like Microsoft Word or like Google Docs. I think that's what Google's cloud-based one is called. So with like Microsoft Word, you can format essays, you can do indentation, you can choose like fonts and stuff. But when it comes to scientific writing specifically, so either for math or just science in general, things like Microsoft Word and Google Docs aren't really that great. Um, the formatting specifically is not that good. There are, you've probably noticed, math formulas. You can insert a math formula, but it's pretty crappy. And it's not what you'll see um, in any academic journals, or even uh, if you've looked at your assignments or whatever from school, you've probably noticed that they're always in like a fancy looking, I don't know, academic format, if you will. Well, that's most likely LaTeX. If it's not that, then it's probably not LaTeX. So if I were to just, I'll show you what I'm talking about. If I were to just go and say like free mathematics PhD papers, just look at a thesis from, I don't know, Waterloo, I guess. So this is someone's thesis. So here it is. So he has this nice title page. He references his university. And if we scroll down further, so he's including nice images, and then all these equations and all these symbols, like you have the subset symbol, the specific symbol to represent like the vector space Rn, it looks like all these nice like math symbols that you'd see in textbooks basically. So this is LaTeX. So he wrote this thesis in LaTeX, just like literally like every other thesis. But you don't need to be at the PhD level to use the LaTeX. You don't need to be doing things like this, like 129 pages thesis worth of LaTeX or whatever, just to use it. I use it to format just my homework, which I'm going to show you how to do today. And I'm fairly new to LaTeX. I've only been using it for a few months. Before that, I was just submitting homework either through like PhotoScan or sometimes like MATLAB Publish, which is pretty good, or just handwriting. But I found that as I get later in my degree, it's nicer to format things in LaTeX. Just for organization issues, it makes the grading a lot easier on the TA, but also for personal issues, I just like to have a record of my homework, and a LaTeX PDF is a lot nicer than just like pages of my handwriting for math. So what I use for LaTeX, I have to get this thing called MacTeX because I primarily do all my schoolwork on Mac OS. So you'll literally just look at MacTeX. Yes, I know it looks like MacTeX, but LaTeX, which is spelled LACTEX, is just pronounced LaTeX. I don't know why, but it is. So on their website, it's kind of ancient, but they have a download page. And I'm not going to re-download this, but all you'll do is you'll download this package. It looks like it's 5.7 gigabytes, so it'll take a few minutes probably to download. But it's very easy to install. It will give you an installer, and then when you open it, it'll literally just say like continue install, and it'll do everything for you. And after you install it, you literally have to do nothing except find the next application, which is, I forget what it's called. It's called Tech Shop. So all of these will come with that Mac Tech when you download it. The LaTeX kit, Tech Live utility, and then Tech Shop. So this is what I actually use to write my LaTeX code in. So if we open this up, it just opens an untitled document. So I'm going to show you a document that's already formatted so I can go over functions. But you can think of this just as a notepad or just any other text editor like Vim or Emacs. This is not an IDE. It is important to note that you can use like VS Code or like even IntelliJ, probably Visual Studios, to write LaTeX. And I don't do that, mainly because I sort of only write LaTeX casually compared to, you probably don't want to write an entire PhD thesis in this, but it's definitely doable. And this definitely isn't just like Notepad where you don't get any suggestions. Like, it has a console and it has highlighting abilities, and you can find out where an error is. But I use this because this is what comes with Mac Tech. It's just very easy to use. It comes directly with it, with all these tools here. And all you have to do is open it up. There's no setup other than making sure you save a destination for your files. And I'll show you how we can actually make a file. So also, it's important to note that LaTeX is entirely free. That's probably the largest reason it's so popular. So Mac Tech is just a package for LaTeX for Mac specifically, but LaTeX is free across the board. So you could also you don't have to go through Mac Tech. Like, here's a homebrew link if you wanted to install it directly from your terminal, but I just used Mac Tech. But LaTeX is free, entirely free. So I have a folder that I made to save my LaTeX documents. And so I'm going to show you this one LaTeX document that I put together for a homework set for a class that I have that's coming up. So whenever you save a LaTeX document, so from here, right now it's untitled, but when you click File and Save, and you choose your destination, you title it, it'll save here, and it'll save these automatically with it. So you'll get a tex file, an aux file, a log, a PDF, and a .gz. So the only ones you have to worry about are the tex and the PDF. So whatever you compile in LaTeX, it'll run a little console window for you, so that way you're actively writing LaTeX. You can see what you're doing. But additionally, it'll create a PDF for you so that you can submit it to Canvas or some other thing, or just email it. Just PDF, obviously, it's the most used file format. So let's open this tex file. So this is like the source file. So now instead of an untitled page, we have this tex file. And so I have it Math 375 Homework 8, and it's saved as a .tex, and it's saved to that folder on my desktop. So just as you would save any other document, I made a folder and I saved it there. You could save it to downloads or documents, but I would just recommend saving it to a specific folder. So far everything should be pretty basic. It's really just like saving any other document. This isn't like code necessarily. I'll get into what LaTeX does because it's definitely not the same as like writing in Microsoft Word, as you can probably already see. But so this is my raw LaTeX folder or file. So when I compile this is going to turn into something like that document I showed earlier, that thesis. But we can look through, and this video is by no means meant to show like every single LaTeX function. I don't even know every single LaTeX function. There's hundreds of them. But I will go over some basic ones and how we actually import libraries or packages. So You always start with this backslash document class, and then in curly brackets you put article. So that's the start. You always put this is like the header file, sort of, if you want to think about it in a programming sense. And then you want to always begin your document, and then you end your document. And the command for pretty much every function is backslash, and then the function, and then usually curly brackets, as you can see from all this. So we begin the document, and then we end the document. So everything in between is what's going to actually show up on the page. So all of these use packages, these are libraries, essentially. So they include like different symbols. So some libraries might have certain math symbols that aren't offered in other ones. Or you might need a symbol from a certain library, a very specific symbol that isn't offered just in the what would be called the preamble, which is just sort of like the default library. And actually, all of these libraries, I'm not using all of these actively. I could get rid of some of these. I just have these in here from another document, but they don't hurt. Like, for example, this use PGF plots. This is so you could actually plot like graphs, like 3D graphs, like nice colored 3D models. But I'm not using that at all on this homework set. But it doesn't hurt to have them in here. I just copied and pasted this template. So the fact that you have these extra libraries and you're not using them, it's not going to hurt at all. And you're not actually like writing code. So there's no consequence basically. You're not going to like crash your computer or your program's going to be too slow to run. All it's doing is compiling to a PDF. So all I formatted as is I made a title. And so go figure, to make a title, you do backslash title, and then inside you actually do what your title is. So I want this to be homework 8. And then author, this is a specific formatting. It'll just make the name smaller. You don't have to, you could just use text, but generally this is a format I like to use. I like to have the title of my homework. So this will be nice large letters. And then the author, which is just myself, which will be smaller but under it. And then the date. So in this case, the date that the problem set's due, right under it. And then I want to begin my document. So this specifies that this is specifically the title bracket. It's not actually part of the document where all the work and problems are. And then under begin document, I put backslash make title. This command specifically takes this and centers it at the top of the page and makes it look like a title. And so if you were to leave this out, it's fine. It's just a formatting thing. So I generally set up my problem sets by just doing like, okay, this is problem 1. If problem 1 has parts A through D, I'll just do part A, B, C, D, or whatever. And then problem 2, like nothing crazy. This is very, very basic formatting for LaTeX. So there's section and then there's subsection. So I want my section to be called polynomial interpolation because that's the topic of the homework. And so that's just going to go under the title, but at the top of the homework. And it'll be in bold letters, so it's easy to read. And then everything under that I want to be a subsection of the topic. So I'll say subsection, and then you'll notice on both section and subsection it uses a star. That's just the multiplication symbol on the keyboard. And then inside I put what my subsection is going to be called, which is just problem 1 in this case. So again, problem 1 will be bolded. And then I actually write what the problem is. So this is just text that's going to show up on the screen. So can you find a degree, polynomial, blah, blah, blah. So everything else, all these like these cache symbols and numbers and stuff, this is how you actually get the nice math formatting. And so I think the best way to do it is I'm just going to show what the compiled form looks like and then go through the commands. So once you've saved this file to a location, you can then click typeset, which will compile your LaTeX document. So you see the console ran. You don't have to worry about this necessarily. This isn't like, I don't use this to debug. It just tells you like where your location is, where it's logging it at. But if you do have errors, you can click go to and it'll highlight like the line where the error is. And also you probably noted that it does indicate lines. So it is like Emacs or like Vim. Like it's a full-on text editor. So we've compiled it, and now we have this nice PDF. So I'm going to split these two screens up. So all of this is now compiled to this. So also, it's important to note, these libraries, these do not show up on the document. These are not text that's meant to be displayed on the screen. You're just importing them in, so that's not going to show up. But then we can see my title. So I made a title, see that shows up larger, and the author of the document, which is me, and then the due date. And when I put make title, that's what centers this. And then everything else is going to be centered as well. So again, I called my section polynomial interpolation because that's the what the homework's over. And then everything else is a subsection. So subsection problem 1, so it just shows up like this. And again, things like section and subsection don't show up. They're specified by these backslashes. So it knows that it's a command. It's not going to show up as text. But what's inside the brackets does show up as text. And so it automatically bolds it for you. And I think LaTeX defaults to just like Times New Roman, I think, which I think is just the font that everybody uses. But you can change it. Like I'll show you a little later. I have an italic word or even like this code. So problem 1. So can you find a degree D polynomial? You notice that I put D in these cash symbols. That's to specify that it's a math symbol, essentially. And I did the same with these sets of points. I put them in the money symbol. And then again, D equals to 2, 3, 6, I put it in the money symbol. So if you can't already tell, anytime you want to write a mathematical expression or a variable, so to specify that X is like a math variable in an equation versus just a letter in the alphabet, you'll put them in these cash symbols. Or you can put them in these backslashes, which I'll show you later, which does the same thing. So that's how you actually specify that you're writing an equation. And it's not that good of an example in this first one because I don't really have an equation. But in problem 2, so I said subsection, again, problem 2, and then I wrote the actual text that's going to go onto the screen. I'm defining a polynomial that we're going to find. So if I were to just take this out of the money symbols, so get rid of the cash symbols, and then compile this. It went somewhere, hold on. Oops, it's all those full screens messing it up. Okay, let's compile this now. It's running into some issue. Oh, that's because I used this, hold on. I'll just say ... manually typeset. I don't even think it's gonna run. Okay, so we have to put these in money symbols, cash symbols. So that being said, it was kind of a waste of time, but the point I was trying to get across is that it'll specifically format it to this. You can tell, hopefully, that like P of X in this case, it like looks nicer than the regular font. It looks mathy. It's like it's almost italicized, which I think is just the default for math. So putting it in those cash symbols is how you achieve this. And it's also how you achieve operators. So if you notice, I have like a naught, say I want all the way up to a sub n, x to the power of n. But all I'm using is like the underscore and then the caret or whatever to indicate something in the power. So if I were to just do that in regular text, it would show up as it shows here. That was basically my whole point of trying to get rid of the cash signs. When I put it in the money symbol, it's telling LaTeX, okay, this is supposed to be a mathematical expression. So this underscore, in a sense, is an operator, which indicates a subscript. And you can also have superscripts. And then in this case, the caret, or the up arrow, whatever you want to call it, is another operator that indicates, okay, I want something in the power. And then also I have this backslash dots. So you can do, so this is supposed to be plus ... up to the end case, you could do ... And when I compile it, it'll do the same thing, but you see it's like not formatted exactly. So what we use instead is this \dots, which is just the math version of ellipses. And it's just more consistent. It just formats it nicer, like it's spaced a little nicer. But really, that's one of those things you can't tell the difference. And then again, and then I want to close the expression by putting another cache sign. So that means that everything inside these cache symbols, is the math expression. So when I close that cache symbol and then type regular text, this is going to be just regular text. And so I think I could probably just show this. If I get rid of the cache symbol and I put it here, indicating that I close it here, and I run it, you could see that it tries to treat the phrase that interpolates as like a variable, because it thinks I'm still in writing in math mode, I guess is what I'll just call it. So you want to be careful where you open and close. So if you're getting issues, it's usually just that probably. And then again, I have this expression, and this is the same thing. I'm not even using special symbols here. I'm just using regular things on my keyboard, but I'm achieving these subscripts by using that underscore again. And so these parentheses are just typed out regular. So you would type it how you would think it would be typed, but because you're putting it in these money symbols, it's going to actually format it nicely, like an equation here. So that's like a very basic idea of how to use LaTeX as far as writing mathematical expressions go. But now let's like actually look at some unique symbols, I guess you can say. So again, so this is now subsection A. And I note that the homework specifically wants it to be by hand, so I just note by hand. And so it's problem 2, subsection A, B, C, etc. So I'm doing the same thing here, money symbols, but now I want to write this. I said derive the system VA equals Y that determines the coefficients, the transpose vector, blah, 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 blah. So in this case, I'm talking about the van der Monde system, which is a matrix. It's a matrix system. So V in this case is a matrix. So you don't have to do anything special with that. You just do the money symbol again to represent that you're writing in math mode. And I'm just going to do a capital V. That's usually how we denote the van der Monde matrix, is with a capital V. But in a system, so AX equals B, or in this case, VA equals Y, A and Y in this case are vectors. And so there's multiple ways you can denote vectors. You could just leave them as lowercase a and y and assume that the person reading it understands that you're speaking about a linear system, which implies that those lowercases are vectors, or column vectors in this case. But you can also put a little arrow above it, which is more common in physics and calculus to denote a vector. But in linear algebra specifically, or forms of linear algebra, you often see just the letter is bolded, which represents that it's a vector. And so that's what I did in this case. I chose to just use the bold lettering because I think it just looks nicer, and I think it's the general format. So to do that, we can see here I say derive the system. So I open the money symbol V, that's our V there, and then I use this backslash. So this means I'm using a command again, and then I type math BF, which is going to bold the letter. So math BF, and then brackets, I put the A inside. So that bolds the A and indicates that it's a vector. And then I just write the equal sign, and then do the same thing for Y, and then close it. So now we've bolded A and Y. It might be kind of hard to tell on the computer, but they are bolded. These are vectors. And so I've shown that using the math BF command. And as far as the commands go, you don't need to know every command. You can very easily just if you're saying, oh, I have no idea what the command is for this random Greek letter or how to denote this matrix, if you literally just look up how can I write let's say like Chebyshev's inequality in LaTeX. Here we go. So they give the formula. This is not what I was looking for. So here we go. This has LaTeX for the graph of Chebyshev's inequality. And so I could just copy and paste this in. And it's LaTeX is not like a programming language. You don't have to think of it like a programming language. Like, okay, fine, this guy gives this code for that, but how am I going to implement it into my work or whatever? You can put it in exactly as it is. All you have to make sure is that, see, here includes a document class, and then we already have that. So all we need is the packages. And then we just want to put it where we need it. So let's see actually if I can get this in. Let me do something easier. Let me just say LaTeX code for normal distribution graph. LaTeX. It's a document class. I already have PDF plots in there. So let's just take this. Math tools. I just want to make sure I don't have these ticks. Explorer. So let's see if this works. Okay, we already began our document, so we just want to take all this and take it here. We don't need end document either. So let's go to the end of this last problem and paste this here. And yep, so now we got the graph. So obviously it's formatted weird, but I'm just trying to show that it's fine to take this code off the internet because it's not sensitive like other languages. There's no consequence. It's not going to interfere because you're not with like other things, because you're not actually writing functions. You're just editing text. And so we have this graph. And see, that's what they showed here. And so we got that here. Obviously, I was just doing this as an example, but you'll format this however you want. So let me get rid of this, and we'll go back to what I was talking about. And I want to. I'm just gonna leave these packages in. I don't even care, just to show this doesn't matter. And so now we're back to what we're doing. Okay. So we've shown how you can write math symbols, specifically vectors, which is what I deal with a lot in CS and applied math. So it's very easy. I just like to use the math BF, which bolds. But my point was for the whole thing is that if you need something, you can just look it up. You can even ask like ChatGPT, how would I show this in LaTeX? And it'll just give it to you, because you're not actually writing algorithms or anything. So you don't have to worry about being sensitive about it. And well, I don't, at least to my knowledge, you're not going to be like using a class that forces you to use LaTeX, and it's like you need to do your own work. And if I see that you're using ChatGPT for LaTeX or someone else's LaTeX, you're going to get in trouble. No, LaTeX is just a tool, like Microsoft Word is a tool or PowerPoint is a tool. So feel free to use the internet and to use resources. And I'll show a resource in a little bit that I use for MATLAB code specifically, or importing code into LaTeX. And this video is probably already very long, but I don't know. It's going to be long. I don't know what to tell you, because I'm talking about a lot of things. Also for this, so I have derived the system VA equals Y that determines the coefficients, and then another vector A, and then I denote a transposed column vector with the capital T for transpose. This is also just very intuitive. So I did again, where is it? Okay, so the money symbol, math BF, to bold my A to represent that it's a vector, but then I just say equal, and then for the bracket, I just use the bracket that's on my keyboard, and then I can say a_0, and it'll automatically turn it into a naught, and then comma, and then again I did this backslash dots to represent the ellipses, or dot dot dot, and then I just typed another comma again, and then I did a_n, and that'll automatically give you a sub n. And then outside of the brackets, all I have to do again is the arrow or caret, and then capital T, and it'll automatically put T in the power here, which is how we denote transpose. So there's no special function you have to call for this. And then, oh sorry, I was talking up here, but I have it here as well. But anyway, most of the stuff that you can think of in LaTeX, once you understand that the way you write an equation is by putting it in the cache symbols, is very intuitive. If you want to write something like f of x equals x squared, you just literally type that, f parentheses x equals x squared. And as long as you have it in the cache symbols, it's going to format it nicely and show x squared as like a nice function with the 2 in the numerator. So going on here, the only difference I have is, so again, we have subsection B, and then this is a MATLAB problem. So this problem asked me to write a MATLAB function that's called function C equals interp underscore monomials, and it takes these two arguments, x and y. So I could have just used this as regular text, so in the same font that all this is written in, but there's a specific command that you can use that gives like this, I don't even know what it would be called, terminal font, code font, programming font, but it's a good way to indicate that what you're referencing is like code. And so in this case, this is just like an outline of what the type of your function should be. But to get that, all you have to do is use this backslash text with 3 T's operator, and then in the brackets, write what the function is. So interp, and I do have to do a backslash and then an underscore for interp monomials. There was a weird, I think it was actually trying to read it as if I was writing a function. So I just put this backslash to indicate that I'm still in text. And then I close the bracket, and that gives me this special font here. And then then I have that returns a vector of coefficients. And then same thing as earlier, I'm using mathbf, the backslash dots for the ellipses, and then just the capital T for transpose, and then given input vectors. And so for these input vectors that I'm talking about, I wanted to center them under the problem to just really clearly show what I'm talking about. So to do this, it's not like Word, where we haven't really talked about formatting yet. It's not like Word where you can just say like hit enter and then click center. You just have to use another command, but it's very easy. So we do backslash open bracket, and then under there we put what our function is. So in this case, it's this vector x equals this column vector x naught to xn that's not transposed. So I wrote that, and then I put another backslash, and then I close the bracket. And so what this does is it says, I want to take this function and I want to center it under the most recent text before it. That's what these backslash and brackets indicate. And because I'm doing two vectors, x and y, I just do the exact same thing under it. I do another backslash, open bracket, and then my vector y, and then backslash, close bracket. And what that does is it formats these two vectors to be under this problem, so centered under it. If you didn't have these and you just put it on a new line, it would just be right here on a new line. So this is how you center, essentially, at a very basic level. There's other formats like left and right to close things in brackets. But again, I don't use them in this homework set specifically. But I was mentioning earlier, if you just want something, just look it up, and literally it'll just give you the answer. You don't have to like know how to code to get any of this LaTeX code. So now we have problem C, which is another MATLAB problem. So it just tells us to do something. So note here that A, again, I'm denoting as a variable. So I have, In this case, I did backslash parentheses A. I did that to indicate that this is the same thing as the money symbol. So you can use them interchangeably. Like specifically with these brackets, you use the backslash rather than the money symbol. But they're the exact same thing, at least the output. And so again, that interpolates. And so again, I wanted this function clearly outlined underneath the initial text, centered under it. So I did the exact same thing. So I just did the backslash brackets, and then I write my function. So here, I don't need to say backslash because I'm not calling a function like mathbf, which specifically bolds the letter x. I'm just saying f of x equals, and then to do fractions, it's very simple. You do backslash frac, frac, which is just obviously short for fraction, and then you put in curly braces the numerator. So in this case is 1, and then you close that curly brace, and then you open another curly brace, and that's the denominator. So you can put whatever you want in this numerator. In this case, it's just 1, but I could say like anything crazy. I could say like, I don't know, x backslash cosine of x. And so that'll always be your numerator, that first bracket. So in this case, I just need 1. That's what this problem is. The function is 1 over 1 plus 25x squared. And again, you just type 25x squared as you think you would using the up operator. It'll automatically do everything for you because you are specifically using this math format. And then after that, I also put a comma, which you can see shows up there. That's not an accident. I want to indicate that this is an intermediary step in my sentence before I get to here. And so to do the comma, you just put it after your function that you write. And so then the text that you put directly under here is what's going to show up next. So I will note that this reads like that interpolates the function 1 over 1 plus 25x squared for the points, blah, blah, blah. And so you can see where I open my brackets and close it. If I were to hit enter and have this next text start on line 49, it's going to go down a line. It's going to hit a new page, and also it's going to not be centered with your previous text. So one thing to make sure is that you do want this directly under that last bracket. That is how you get specifically this format, to where the 4 here lines up with this line. So stuff like that. And you'll just notice it when you're writing. You'll be like, okay, how does this not format? Let me look it up. Oh, I have to do this. You'll notice that some things are case sensitive. I wouldn't even say case sensitive. Just that might be the wrong term. Just sensitive to what you're doing. And so again, I just used the, in this case, I used the backslash again to show that it's the same thing. But x of I, we already know to do this. I, this isn't a special symbol. This is just the I. It'll automatically use this I. And then h. And then again, I have another fraction, 2 over n, so I do backslash frac. And then this time, my numerator is 2 and my denominator is 10. And then I just put a comma because I'm separating this and saying for the points x of I equals negative 1 plus IH, where h is equal to 2 over n, for I equals 0, for the values of I 0 to n. And so basically, I've been saying it over and over and over, but just so I don't have to keep explaining, and it's probably already obvious, and I'm probably just being redundant. As it looks is how you type it as soon as you format it and tell it that you're doing a math equation. So if you want to put a comma, you just put a comma. If you want to put an n, you just put an n or an h. So I've been trying to just drill that point in because I know that this over here looks nothing like this until you actually zoom in and look at everything. So the regular text, I use the money symbol again to get these nice functions. And then again, I'm saying I'm referencing a certain MATLAB function, plot. So I'm going to use that backslash text with 3 T's, which gives me that nice like programming font. So it looks like it bolds it, and it just gives it this more like teletype font. Teletype, I think that would be the good term for it. And so it automatically splits the page up here. So this was the end of page 1, and it indicates page 1, page 2, and then it just continues the text on the next page. You can be very specific about this. You can use, I know there's a command that you can use to end the page. So you can write a problem on one page and then end it, and then the next problem will start on the next page, or you can shove text into the same page. I usually just leave that alone. I think this is fine. Sure, it doesn't look the best. Like plot the polynomial and, oh, 1, the page broke and we're here now. But I think it looks fine, and I think it's pretty standard. Like you have the same issue on Word. Like you'll hit enter and you'll all of a sudden be on a new page. Again, it's all personal preference. It's still going to work. So if your teacher is really strict about something like that for some reason, that's just something you can do on your own. You could just format it yourself to make sure that this text all squishes onto this one page, or that this problem is pushed to this page first off, so you don't have this. But I don't really care. I think it looks so good still. Let's see, what else am I doing? So f of x is just, I'm using the money symbol again, parentheses. So I guess it is important to note that, where is it? Recall Runge's theorem. Here it is. You can nest these money symbols and functions inside of your regular text. So I'm nesting inside these parentheses. The parentheses aren't going to screw anything up. Again, that's sort of, parentheses don't actually mean anything in LaTeX unless you will tell them to mean something. And so here I'm saying still on the interval -1 to 1. So I'm using this element of symbol. Yeah, it's not epsilon, it's element of. So to do that, it's not element of. The way they call it is this \n. So you'd say money symbol, because you're writing math now, x \n, and then brackets -1 to 1, close brackets, then finish your money symbol. Yeah, that's just LaTeX way of. So again, that's just something you learn. How do I say element of in LaTeX? And it'll say, oh, it's \n. So you're saying x in the interval -1 to 1. And then I can just close my parentheses, add comments. I'm just typing regularly now. Here, I'm using math again, n sub fine, blah, blah, blah. I'm typing, I'm saying try these points. I do the money symbol again. This is all regular text. And then again, I use this \text with 3 T's to get this teletype font, because I'm specifically referencing a MATLAB function, like a coding thing. Let's see here. Problem D is the same. Just typing normally. I have f of x. These are all in money symbols. Difference values for the polynomial. So x sub I is just money symbol. F of x underscore I, that gives you f of x sub I. And then the problem asks, or I ask for the condition number. So the condition number in numerical computation is generally denoted as the Greek letter kappa, and it's of a matrix. So in this case, we're talking about the Vandermonde matrix. So I know that's V, so I want to say kappa of V, of the matrix V. So to get a cool Greek letter like this, you would say, let me find out where I am. So I have, I should also note that I have the word interpolatory in italics to specify that this is a definition. So to get the font to be in italics like this, I call / and then text it, which is just short for text italic. And so all these other fonts out there that exist, you would just look at a list of what the command is for that font. But I know that italics is just text it, and then I do curly braces, and then the word that I want, and then close curly braces, and that'll put that in italics. And you could do, it doesn't have to just be one word. You can do a whole sentence, like this is a whole sentence in italics. When I publish this, see, it's going to take this all and put it in italics. So very easy, very nice. You can use bold or underlines. I just like to generally put my definitions, or a word that I guess refers to a definition, in just italics. And then, so again, normal math. But so getting back to this kappa symbol, all we do to get that is we open the money signs again to indicate that we're doing math, and we do backslash, and then this Greek letter is called kappa, and then curly braces, and then I do parentheses V because I want the format to include parentheses. And that's it. I just call backslash kappa, and it gives me the Greek letter kappa. So like, let's say if I did epsilon. Oh, epsilon. Let's see if the Greek letter for this shows up. So now we have epsilon, lowercase epsilon. Or let's say gamma. So now we have gamma. So you can probably see pretty quickly that the trend for getting these Greek letters is simply just using the backslash operator and then typing the name of the Greek letter. And then to get like capital Greek letters, there is a specific function for that exists as well. So I have kappa V, and then I close the money symbol, and then of the matrix, money symbol V. So basic. So we're not doing anything crazy now. We're just calling a Greek letter by its name using the backslash. So here I have talking about solving this problem in the monomial basis. And so again, I want to center this fact that we're showing under the problem. So again, I just use the exact same thing. I use a backslash, the open brackets, and then so this is kind of a crazy expression, but all I'm saying here is that the condition number of the matrix V can be shown to be approximately pi to the power of -1, or 1 over pi times e to the power of 4 times 3.1 to the power of n. It's a lot easier than it looks. So I, again, do backslash kappa because I want that Greek letter kappa. And then I want V. So capital V, I just put in the parentheses. And then this tilde, this squiggly, is a function. It's a special symbol. So again, I do another backslash, and then I do SIM. That's just that's their way for calling it tilde. I don't know why. I think it's just meant to be similar, because that's what we're saying. We're saying it's similar, but the symbol is tilde. So you see backslash sim, and then for pi, well, believe it or not, it's just backslash pi for pi. And then I do the caret top again and raise it to the -1. And then I can just write the letter E. You don't have to do backslash Euler or something like that. So E, then again, to the power of, but this time I have a fraction in the numerator. So I did E to the power of, and then brackets, and then backslash pi over 4. But let's see if we can be even more specific. So what if I wanted, instead of it to show up like this, I wanted it to show up like a nice fraction. So say backslash, let's say backslash frac, backslash pi, close brackets, open brackets, close brackets. So we've nested all these. So let's see if this works. I might be screwed up. So there we go. So now we have pi over 4 as a nice fraction in our numerator. But I think the other version was a little bit more clear. That's just what I got out of the textbook, so I'm just going to do that. I'm just going to have pi backslash 4. And we'll go back to what we had. So we have pi over 4. And then times 3.1. So believe it or not, you just type the number 3.1 and then to the power of n. And then I put a comma again. That's very specific. That's not an accident. So it just goes to show that even the most complicated, right, this isn't the most complicated. It just looks kind of more complicated than it is because of the tilde, really. It's very simple. The format is the same. You always you would type it how you would think you would type it, but because those symbols are on your keyboard, you just use the backslash and then the name of it. And then after you've called it, then you can use like parentheses or to the power of, stuff like that. So again, now talking about This regular text, Lagrange interpolation, blah, blah, blah. These aren't special symbols. I'm literally just putting I in parentheses. This is all normal text. This I'm putting in money symbols because it's a function, or it's not a function, it's just a math. And so now we're on problem 4. So again, this is normal text. I'm just typing here. And so I'm talking about interpolating some function using the Chebyshev points so that are given to me. So again, money symbol. Again, I'm centering this under it, so I'm using the same thing. I'm using the backslash brackets, and then I'm just writing this function. So I'm saying x underscore I equals, and then I'll show you that you can write just cosine as COS, but it will look slightly different. So if I just write COS, you'll see that it shows up like it's slanted. It looks like italics. So there is an actual function for cosine, and that's just backslash cosine. And if you look at cosine now, you'll see that it straightens out a little bit. Again, minor differences. Things like sine and cosine and tangent and secant that can be spelled like that, it doesn't matter. But there is an existing function for cosine and sine, so I just want to use that to stick with the format. And then again, this is a fraction, so it's cosine times this fraction, so I just put cosine out in front, and then I call it backslash fraction, or frac, and then my curly braces, and then I want my numerator to be parentheses 2y plus 1, and then backslash pi, because it's times pi, close my curly braces, open another pair of curly braces, and my denominator is 2n plus 2, close it, and then I just say comma, I equals 0, comma, backslash dots to give me these ellipses, comma, n, comma. And so that's all it is. So I'm just typing it again as I would type it. And for all the symbols that don't exist on my keyboard, I just use the backslash. And so, comma, and then I continue my next hex and Lagrange interpolation. Can you get the interpolation, blah, blah, blah. And so, yeah, same as earlier. And so again, for all these, I forgot to have been mentioning, these are all subsections. This is what I'm calling them. So I'm saying backslash subsection star, and then I'm putting the type. Well, that's how I get the bold here. And then everything under that is just regular text. So now we have problem 5. So this is the last problem. So the exact same thing. So I just start my normal text finally for the functions, blah, blah, blah. And then I put backslash brackets, and I'm centering these under it. And then as we've been writing them earlier, I'm saying just backslash sine of x. For the absolute value of x, I'm literally just using the bars that are above the enter symbol on your keyboard. I'm not using like backslash absolute or whatever. I think there's a function that exists for absolute values, but for something like the bars, they're just on my keyboard already, so I'm just going to use them. And then comma, and then tabulate the maximum error. And so now I have this maximum function. Again, looks more complicated than it is. I just have, so it's centered under the text. So I have the bracket again, and then I have backslash max, because it's the max function, and then the underscore, and then curly brackets, and that's where this indice is going to go to indicate the range of my max function. And so I have backslash max underscore, and then x backslash in. If you remember from earlier, that's how we denoted element of, and then brackets -1 to 1. And then I close the curly brace, and that brings me back up to the normal line. So that gives us our max with our indice. And then for this, again, this is the absolute value, so I just write, I literally just type this on my keyboard. I just do the bar, and then f of x minus p of x, and then I put a comma. And so then, and then I finish the text as a function, blah, blah, blah. So this is the homework that I wrote up, and you probably noticed this isn't my answers. I just wrote down what the assignment was, I guess to avoid, I don't know, I don't want to get like expelled for giving out answers or whatever to the Forsaken Math 375 at UNM. But so I've gone over just, this is basically how I write all my math homeworks, and I'm not using anything crazier than this generally. just more Greek letters, more symbols. So like when you're doing calculus, there's a symbol for the integral, there's a symbol for sigma to represent the sum or the Taylor series. But in this case, this homework focused mainly just around functions and linear systems, so vectors. So this is actually like a pretty easy example as far as the functions go. But again, for if you need to know how to set up the code for an integral, you just look it up and you put it in, and then you'll see, oh, this is where my indices start, so this is the general form of the integral. I want it to look like this for my problem. You just adjust it. It's very easy. So the next thing I wanted to show is that this class specifically uses MATLAB. It's because it's a numerical computing course. So how do I do the work in MATLAB and then get it over to my LaTeX document? So there is something that exists for that. So I'm going to look that up and find it on Overleaf, which Overleaf is another source I wanted to mention. This is a great source for LaTeX. I'll go to their homepage. Overleaf is a cloud-based way to write LaTeX. So you can write it directly from their website. So it's all cloud-based. So it's like the Google Docs, I guess you could say, of LaTeX. But it's very nice because it has like all libraries built in already. And that's not what I'm using. I'm using a very specific editor. I'm using an editor. So this is not cloud-based. This is on my hard drive. But anyway, Overleaf is free again, but it also has a lot of resources for LaTeX. So LaTeX commands, basics like bold, italics, underlining, lists, certain mathematical expressions, languages, because you can just do more than English, obviously. But specifically what I wanted to reference is how I can include MATLAB code in LaTeX. So it's very easy. So we use this package called MATLAB Predifier. So I want to check that I already have it in here. Yeah, so I already included use package MATLAB Predifier. And so once I have that, I can basically run this command. So \begin, and then my LST listing, and then I end it, and then my MATLAB code will go in that. And so luckily it gives me a nice example. So so I don't need document class. I already have that, and I already have the package, and I already have begin document. But so we want to begin list or LST listing, and then it's going to just, inside of where it's set up here, options, that's just how you stylize it. So I want this to look like the MATLAB editor, which means it's going to assign variables and stuff with colors that the default MATLAB editor, which I have down here, would show up as. So let's copy this. And again, we don't need end document because we're putting this in existing code already. So let's put this at the end. Also, to make comments, you just use the modulus symbol or the percent symbol. So I'm going to say this is an example of MATLAB. And this is not going to show up in your final document, your comments. This will just be specific to your editor. So if we copy this, so we begin our LST listing. This is all our MATLAB code. So it even has comments here, sample MATLAB code. So when we publish this should come through as normal MATLAB code, or at least on our document. So there we go. So this is how I take over my MATLAB code. Obviously, it's to a greater extent, but what I do basically is LaTeX is not going to run and compile my MATLAB code. So it's not going to, if I write a function in MATLAB that does something, it could produce a graph or a table or something, or calculate something numerically. I can't just copy it into LaTeX and then publish my LaTeX document, and then it's going to give me my output, but it will just show the code. So if a problem asks me to write a function, I'll say, okay, I write the function in MATLAB, I do the work, I run the code and make sure my answer is right, and then I just take the code over, and using this formatting, I can put the code into my document to show it on my homework. Be like, hey, here's my MATLAB code. And then I can also take the output of the code that, MATLAB gives me, and I can paste it again into my LaTeX document and I'll usually use the \text with 3 T's to indicate that it's like the output of some program. So it'll put it in that teletype font. And so that's a very simple way to import MATLAB code over. And again, this is what you'll have to do for any code. This isn't unique to MATLAB, obviously. I was just giving this example because I use MATLAB for this class. But don't treat LaTeX is not it's not a programming language. It's not a compiler, or sorry, it's not an IDE. So you can't write code in here and then it's just going to work. And you're also going to have these documents. This is just a way to format text. It's just a text formatter like Microsoft Word. So if you're writing C again, you're just going to have to bring it over. But it's pretty easy to learn. I know this video is really long, and I'm not sure how much information I got through, but I think it was a lot of information, or enough at least, to get started. I went through an entire document and how I made it, as well as gave some resources. So, yeah, I don't know. I guess I hope this helped a little bit. I just thought it'd be fun to make this because I like using LaTeX. I never used it, and it's sort of it's like the top program for writing scientific papers. So if you know how to do this, you might be able to impress your teachers, but then also it's very good to know for, I don't know, maybe when you get a job in the industry, or if you continue in academia. In grad school, you're probably going to have to do like all your math homeworks in LaTeX. And once you're good at it, you'll be able to go pretty fast. I could type this up in just a couple minutes because I know how to use LaTeX, and this is not hard. But then also I showed the instance of a graph. There's you can do a lot of cool things with LaTeX. And so you'll just discover those things by using LaTeX. So don't feel intimidated by it because it seems like you're writing code. You're not. You're really just formatting things using certain keyboard symbols. That's all it is. Yeah, you have to include libraries. Like, oh, it looks like C or Python, but it's not like that at all. You're not writing code, really. So if this helped, I guess good on you, and keep LaTeXing.